This is some guidance for the simple harmonic motion experiment. Okay, so by the end of the lab, you should have a table with T and M. So T is your period and M is the mass. We're going to turn that into a graph like this. We're going to plot T squared against the mass, and you should end up with a line. Just to be clear, the T values you should use should basically all be for the same spring, but they don't have to be for the same mass because obviously you're plotting mass here along the bottom. But yeah, so just make sure you're using the same spring. Because the period only depends on mass and the stiffness of the spring, even if you've pulled it down by different amounts and stuff like that, it shouldn't really make a difference. So yeah, as long as this is all for one spring and you're increasing the mass, then you should get decent results. So that's all you need to do for the graph. I'll just zoom out a bit there. So the second part is dealing with the equations. So you start off with this equation being given to you. So the period is equal to 2 pi over omega, and you're also given omega is equal to square root of k over m. Without explaining those at all, we can sort of just work with them. So we know that we need t squared because that's what we have with our graph. So if we get t squared, and okay, so just to be clear, we have t here and we're going to square that and we end up with this. So our t pi over omega comes t pi squared over omega squared. And we're going to move along to here, and you can see that we've got omega is equal to square root of k over m. We're just going to replace our omega squared over here with literally omega squared. So we end up with k over m. And then we can rearrange that so we end up with m on top and k on the bottom. So one thing you can do with graphs like this, if you have your y-axis and your x-axis, you can do the y divided by x. So look at this, imagine if that c is equal to 0. If you do y over x, you end up with m, and m is your gradient. So that's kind of what we've done here. Just to be clear, this m means gradient, but this m is mass. So we've got t squared over m is our gradient, and that's going to be equal to 2 pi squared over k. I'm going to zoom out a bit just so you can sort of absorb all that. But the long and short of it is you can rearrange to solve for k, and k should be t pi squared over your gradient. Just to be clear, you get your gradient from XL. Okay, so hopefully that video sort of explains part B and how you're sort of meant to solve for k for your spring.